Hi guys, welcome back to Maths 911. Don't forget 08600 62847. That's the number you need to dial if you want us to answer your maths question right here live between 5 and 6 o'clock, Monday to Thursday. We've got a caller who's called through, a Kumzi, and he's given us a question. We're just trying to get him on the line, but I think in the meantime we're going to go ahead and we're going to try and help him with his question. We're just struggling a bit to get hold of him. His question is, he has asked us to sketch the graph of y equals tan 2 theta. And what I propose we do is we first look at the graph of y equals tan theta. So if we look at the horizontal axis, we will make that the theta axis, and we will have the numbers 90, 180, 270, 360, and we will do the same on the negative side. In the examination, you are told between which two numbers on the horizontal axis you need to sketch the graph. So they would say to you, sketch the graph of y equals tan 2 theta for theta element of minus 90 to 180, or any other interval that they want you to sketch the graph in. You know, graphs generally are about point-by-point plotting. In one of the exams, in one of the maths exams written at the end of last year, they were asked to sketch a graph and they really didn't recognize what the shape of the graph was. So what were they to do? The basic idea behind graph sketching is to try and plot points, and from the points that you plot to try and envisage what is happening with the graph and then draw the graph from there. So what I want you to do is I want you to get your calculator handy, and if you don't have your calculator in front of you, I'll talk for 10 seconds, which will give you just enough time to go to your room, get your calculator and come back, because you need your calculator for this. If you take your calculator and you simply make sure that your calculator is in degree mode, and you enter tan of 0 equals, tan 0 equals, it gives you the answer of 0. If you enter tan 45 equals, it gives you the answer of 1. And if you enter tan 90 and press equals, it gives you an error. So let us look at that. Tan of 0, that gave us a point, which was 0. Tan of 90 gave us error. And tan of 45 gave us 1. Now, you will notice that I've drawn a vertical dotted line in line with 90. And what I want you to do is I want you to take your calculator. I'm not actually going to demonstrate it, but I want you to sit with your calculator on your lap right now, and I want you to go tan 45 again for me. And yes, I need you to shout so that I can hear you. That's right. The answer is 1. Good. Now I need you to go tan 80, tan 89, tan 89,9. And really what I want you to do is I want you to punch in numbers that go from 45 to 90. Remember, if you type in 90, you're going to get an error. If you type in 45, you're going to get 1. Type in tan of 80. What do we get if we type in tan of 80? Let's have a look. Tan of 80 equals, gives us 5,67. So when we go to 80 degrees, we are in line with 5, something. If we type 89, tan of 89 gives us 57. It's way above. So what's happening to this graph? If you plot points, if you've got lots of time on your hand, plot tan 1, tan 2, tan 3, tan 4, tan 5, all the way to tan 89. it's a bit ridiculous and you need a lot of time on your hand. But you could do it. And what you would find is that the graph would gradually, your points would gradually move up in a smooth curve, and they would simply, your graph would go straight up, getting closer and closer to the vertical line which I've put in. Hence, that vertical line being the asymptote. But the minute you go tan 90, you get an undefined, you get an error. The same thing if you go to the negative side. If you try and work out tan of minus 90 on your calculator, you will get an error. We put an asymptote in that place. Tan of minus 45 will give you minus 1. And all the other points will line up nicely on a smooth curve that does exactly that. And that there is the tan graph. That is the tan graph between minus 90 and 90. That is y equals tan theta. And what we find is that this graph repeats itself now. After, you can see from minus 90 to 90, that is 180 degrees. If we go from minus 90 to 90, we go through 180 degrees. And the same graph will repeat itself over the next 180 degrees. So if we look at the next 180 degrees, we would have an asymptote in line with 270. And then in the middle, we would be at naught. We would proceed and have a smooth curve moving up towards the asymptote and down again towards the asymptote. And we can check that. Let's check. If we type in tan of 180 degrees, what do we get? We get 0. Tan of 180 is 0. Do tan of 270 on your calculator. And because I've got an asymptote there, you're going to get tan of 270 is going to give you an error on the calculator. How about tan of 360? Type tan 360. What do you get? I need to hear you. Good, I can hear you. You're all shouting 0. And then if you type something between 270 and 360, you'll see you'll get a negative 1 or something that is negative. And hence, that part of the curve now goes down. This graph is the same over 180 degrees, but from 270 to 360, we only have 90 degrees. And if we want to stop the graph at 360, we can only draw half of that branch. You can see the pattern. It's now easy to simply put in the asymptote, go to the middle, and follow through with the pattern. Really simple and really easy. That there is the graph of y equals tan theta.
Keep this frequency